and welcome to Embedded Development with the Zybo Board. This will be a short video on how to get started with the Zybo Board and Embedded Development, and we'll be covering a lot of things today. One of them will be interfacing our FPGA fabric with the ARM processor in the Zynq7000 series chips made by Xilinx. You can find tutorial information, for example, the C file and so on. Search for Zynq Books Tutorials online. You'll actually find a text version of this tutorial, and this is what I'm sort of basing this video on. And you can actually find that straight from the source. Anyway, the first thing you'll need is a Zybo board, and you can buy a Zybo board from Xilinx or DigiKey. Digilent also sells the Zybo board. I purchased mine off DigiKey, and it came in a couple days. Notice the part selection here. There's two boards that Digilent makes. One of them is a Zybo, the other is a Z board. Yes, it's quite expensive. The chip itself, say you're going to buy the BGA, is about $60. So it's quite expensive, especially if you're going to put it on your own custom PCB. Generally, it's easier just to develop this way. You don't have to worry about that. Not until you're going to production, if you're going to go to a production environment. Anyway, the first thing you want to do is add the Zybo board configuration files to Vivado. And the way you'll do that is you'll find the file in the tutorial folder from the Zybo Book Tutorials that you found online. I hope you've been able to find that. Simply copy the folder over to your Xilinx folder from sources in the board part directory. Notice the B.3, that's the current version. So just move that over to the board files in Vivado. I'm using Vivado 2015.2. It's the current stable version. And that's just a copy and paste. That's all there is to it. When Vivado opens up, it will recognize this board automatically. You can sort of look in the files contained in the board configuration file. They look like this. They have different part numbers and pin configurations, I/O standards, and so on. It should look something like this anyway. So that's 3 XML files. It's just easier to just copy this over than typing it out. So just copy that over into your Vivado directory. Next, we want to create a project. We're going to create a new project in Vivado. I'm going to call this Zybo project. Now I'm not going to import anything. I don't need to import any code. We'll start from scratch. So we can select the board straight off the next screen here as such. Select the Zybo. Now if you didn't copy the folder into your Vivado directory, this would not appear. You wouldn't be able to do this step. So if you haven't done that, go back and copy that folder into your Vivado directory in the board part directory. Anyway, so the first thing we want to do when we get to the screen is create a block design. It's going to ask for a name. You can call it whatever you want. Just click OK. Next, right-click on the canvas and add IP. So we're going to right click, add. You can use the search box. If you type Zybo in there, it's not going to work, so type Zynq. Zynq is the processor that we're using, and select this one. Do not select the BPM. Select the one that isn't the BPM as shown. So this is what happens. It adds this to the block design. So next you want to run the block automation. The default settings are fine, so just let it run and you should get something like this. It connects some of the outputs to fixed I/O and DDR. So those are on the Zybo board. Don't forget to save frequently. Save the block design. You'll see an address tab pop up. It should look like that. Next we want to add more IP, so we're going to add GPIO. These are general purpose input and output pins or ports. This is an AXI block. AXI is a protocol. We can run the connection automation again. This is a memory map process. So this allows the Zynq processor to communicate with the FPGA fabric through the AXI protocol. Anyway, on the GPIO, select LEDs, _4 bits, and leave the S_AXI the same, and just let it run. We'll run the block automation. Notice there aren't really any errors in the Tickle console. Should look something like this. No errors, no warnings. I'm going to save our work again. It's always good practice to save periodically. So we need to create a hardware wrapper for this. It's not quite ready to export. So create an HDL wrapper. Right click on your design in the source section and click on create HDL wrapper. Choose the default setting and it will automatically generate the VHDL code for your project. And you're welcome to explore that. It's quite complicated. It's a lot easier to really let the toolchain handle this part of the process. This is the memory mapping between your GPIO and what your ARM processor will be communicating with. Next, we can generate a bitstream file. So click on Generate a Bitstream, and this will take some time. So just sort of let it run. Now this took me about 5 minutes to generate. I've sped up the video to spare you that agony. Now your computer might be a little bit faster than mine, so it should take less time. If you look in the upper right hand corner, you'll see it's sort of working on generating that bitstream. When it's done, it will say bitstream complete. And we can export our bitstream file. We're going to look at the hardware at the moment. We can open our synthesized design. This is what it looks like on the chip. This is how the netlist is routed. Two different parts. On the right we have the FPGA fabric, and on the left we have the ARM section. What you're looking at are slices and routing interconnections. And on the left is our ARM processor and the routing to the FPGA fabric. There's quite a bit of routing that's taken place with very little code being done. Most of it is due to the AXI connections. So now we're going to export the hardware, and you want to include the bitstream. This will export the bitstream to the local project file. At this point, we can open the SDK, Software Development Kit. If you do not have SDK installed, skip to the end of this video. The last couple minutes will show you how to install SDK. If you have already installed Xilinx Vivado, but forgot to install SDK, so you don't have to re-download the entire environment over again. You can just download the SDK and install it, and it should work well with Vivado. So this is SDK. We want to create a new project. So create a new application project and name it what you would like. Click on Next. Don't click Finish at this point, just click Next. And we're going to create an empty application. In this empty application, we can import our C file from the project folder from the tutorials, which is what we're going to do. So at this point, click Finish. So this has created an empty C project for you, and it has imported our bitstream. Well, actually, the Zybo wrapper created in Xilinx Vivado. This system file shows you the peripherals added to the design, those things that were dropped into the canvas in Vivado. So we are going to import our project at this point. You can just follow along. We want to import a file system. Click on Next and browse the folder that contains the C file. In the Zynq Book Tutorial folder, go to Zybo and click as shown. Just click OK, and then select the C file. Click Finish. So this imports a ready-made C file, which you'll see in a moment what it will do on your Zybo board. We can double-click on the C file and take a look at what's sort of happening here. We have a main function that runs this LED function, which contains a couple steps, including initialization, setting port direction, toggling the LEDs. There's a delay. So this whole function sort of happens in main. It's called and returns a status. If the status is bad, you'll get an error. If something isn't working properly, we'll simply exit. Otherwise, it's going to continue exiting this while loop forever and ever. While one. Here's the axis mapping. Again, we're memory mapping here. The address space from the Xilinx Vivado for the GPIO port corresponds to what the ARM will be addressing. So your C code can interact with your FPGA modules, and this is done through memory mapping. So now we can program the FPGA fabric. Just click on Program. And now we can program the ARM section. So right-click on the project folder and go down to Run As and click on this field here. And this will let it run. So we'll take a look at that momentarily, what this program looks like on the Zybo board when it is running. So here's your Zybo board. Should look something like this. I have a USB cable. You can power the board off this cable, or you can use a 5-volt power plug adapter to power the board. Of course, the USB is required to program the ARM and FPGA. Don't forget to move the jumpers where necessary. And the JTAG programming is done with the right jumper on the section on the right side of the board. Power it on. At this point, it is not programmed. So I'm going to program it once again. It's very important. If your Zybo isn't recognized, go into Device Manager and make sure you have a USB serial port. Make sure the COM is there. Notice the manufacturer's FTDI and the driver date and the driver version are extremely important. That they match in 2 sections. So both ports, the common LPT port, right? So, and down here in the Universal Serial Bus Controller, there's a sort of sister driver that's also running. And these 2 driver versions must be the same, or you will be unable to program the Zybo board. It just simply won't work. If they're not the same, update the driver. So I ran into some trouble with this and scoured online to no effect. In fact, I reinstalled the entire Vivado Studio until I figured that out. Anyway, program the board. Notice just a red light is on, indicates power. When it's programmed, you have a green light that tells you the FPGA fabric has been programmed. And next we can program the ARM, which I'm doing now. And for this particular program, you'll see this. So we're just toggling LEDs. This is the hello world of the embedded development universe. Of course, if you power it off, you're going to lose everything. so we can program it once again. Remember, this is an FPGA device as well. When it loses power, your SRAM is erased and you lose your program. And there's ways around that. I will explore those in successive videos. If you forgot to install the SDK, then go here, right-click on the icon in your system tray, and you want to add. So you don't have to reinstall Vivado from scratch. You can simply add the SDK. So again, you need your username and your password. So don't forget those. Those are required for Xilinx authorization and downloads. And you can select the SDK here if it is not installed. And that will save you 2 hours of download time. If you have a DSL connection like I do, you will not have to reinstall Vivado. You can simply download the SDK this way. It's simple enough. So thanks for watching. If you want to do more with embedded development on the Zybo board, stay tuned for the next video in this series. Thanks for watching.